Hi, Algebra 1. So we are on Chapter 2, Section 4, solving multi-step inequalities. We're jumping a few sections because these are very similar to solving equations. But now, let's spell this correctly, inequalities. We have those inequality signs. So the first thing I'm going to do is actually jump in with examples, and then we'll come to our rules for this one. I think it's kind of best to work backwards. So I'm going to start with 5x minus 3 is greater than 27. So it's the same rule so far as solving for your equation. So of course, adding 3 to both sides, we get 5x is equal to 30. Divide by positive 5 here. Now there's a reason I'm saying positive. We get that x is greater than 6. Now, I always like to go ahead, I like to throw these on number lines as well so that we get an idea as to what numbers we're talking about in this situation. And we're talking about any number that is greater than 6. So 6, 7, or sorry, not 6, but 7, 8, 8.5, any number greater than 6. So far pretty easy, and I wanted to show you right now that right now it works with fraction busting as well. So for example 2, we are going to have 3 over 7 plus 5 over 14 x minus a half x is less than negative 3 over 7 x minus 1/7. Okay, as always, feel free to pause. But if you notice here, this one is an easy fraction bust if we multiply by 14. I have a lot of terms here, so I have to write 14 a lot of times. If you get kind of tired of writing, you can of course just parentheses and put it around everything and then put a 14. So 14 divided by 7 is 2 times 3. We have 6 plus 5x minus 14 divided by 2 is 7 times 1, 7x less than negative 6x minus 2. Ooh, this one turns out to be pretty nice. I have 6 minus 2x is less than negative 6x minus 2. You guys have actually gotten pretty good at your, I'm going to go ahead, I'm going to add 6x on this side. And at the same, actually no, that's okay. You guys are going pretty fast, but I want to show you how we can solve this one. So we get 4x is less than negative 8. When we divide by positive 4, we get that x is less than negative 2. And again, throw it on a number line. Get used to kind of putting these on here. So we have 0, negative 2, numbers less than negative 2. Okay, so far they've been exactly the same as solving equations, except we have had an inequality on there. So I'm going to actually say that you don't have to write this next part. I'll let you know when you get to write again. So you can go ahead, you can say, do not have to write. You can watch only. So what I like to do here is I like to start with what's called a true statement. So I'm going to start with 10 is greater than 6. We can all agree that that's true, right? 10 definitely is greater than 6. Now we're going to go ahead and we're going to change this around a bit. So I'm going to start by adding 6. And if I add 6, I have to add 6 to both sides. So 10 plus 6, that's 16. 6 plus 6, that's 12. That's 12. 16 is still greater than 12. It turns out to be true. Yeah, we can add 6 to it. Okay, now, and again, I'm always starting with this 10 is greater than 6. What if we subtract 2? So 10 minus 2, that is 8. 6 minus 2, that's 4. Well, 8 is still greater than 4. It's still a true statement. Let's try something else here. What if we, well, adding a negative is still subtracting it. What if we multiply? I'm going to multiply by 3. So I'm going to multiply each side. So 10 times 3, that's 30. And 6 times 3, that's 18. 30 is still greater than 18. We are still working with true statements. Okay, now I'm going to go ahead, I'm going to try something here. I'm going to do a different color, orange. I'm going to multiply by a negative 5. Put that in parentheses so you can really see it. So multiply by a negative 5. Okay, so 10 times negative 5, that's a negative 50. And 6 times negative 5, that's a negative 30. But 50 is not negative 50 is not greater than negative 30. This now turns into false. It doesn't work. So kind of keep that in the back of your mind, that when we multiplied by a negative, we got a false statement. Now, the last thing that we have to do here is that we have to divide. So I'm going to first divide by 2. Divide by 2. So I have 5 and 3. That still works. I get a true one when I divide by a positive number. But you could probably guess this right now, that when I divide by a negative 2, so now I have 10 divided by negative 2. That's a negative 5 and a negative 3. Again, we end up with that false statement. That false statement. So the moral of the story here, and this is where I'd like you to go ahead, pick up your pen again and write this, and I'll star it for you. The moral of the story, is that you need to flip inequality sign when multiplying or dividing by a negative number. So really go ahead, kind of etch that into the back of your mind there. So why don't we go ahead and pick up with some of our examples here to prove to ourselves that we definitely have to. So we are on example 3. I'm going to have x over negative 3 plus 9, is equal to, is less than or equal to 15. All right, so I'm going to do this with inverse operations, but you could, of course, fraction bust if you wanted to. So when you subtract 9 from both sides, you get x over negative 3 is less than or equal to 6. So now I need to multiply both sides by negative 3. And this is that part where I am multiplying by a negative. So this is the step where I need to flip my inequality. So the first thing that I'm going to do is I'm going to flip this inequality. I still keep the equal sign on here because that's part of the inequality. So I'm going to flip that around, and I get that x is greater than negative 18. Negative 18. Now, if you went ahead and you fraction busted, you would have flipped your inequality in this first step because you would have multiplied everything by negative 3 in that first step. All right, let's give ourselves a few more examples with flipping because it gets a little tricky. So example 4, we have negative 5x plus 3 is greater than 2 times x minus 6. So it's the same steps as we have with solving equations. We first need to distribute and combine like terms. So now we have 2x minus 12. So if you notice here, we could actually go ahead and add 5x to both sides and keep the x positive. But for our example here, I want to keep that coefficient negative. So this is negative 7x plus 3 is greater than negative 12. Now if I minus 3, negative 7x is greater than let's see here, sorry, negative 15. And now I need to divide by negative 7. So you need to flip. This is the space where you flip. Flip that inequality because you divided by a negative. All right, and then we're going to go ahead and this turns into x is less than positive 15 over 7. So really be careful there on your inequalities. So just like I said before, we're gonna now go over our steps and things that we want to be careful of. I can go ahead, I'm gonna do purple for this one. So first things when solving inequalities. The first thing to notice is that it's the same, right? Same as solving equations, except for these few things. Number one, when multiplying or dividing, by a negative, flip the sign. Flip it. Flip that sign when you're multiplying or dividing by a negative. Now, the other thing is that, and these are kind of the same idea, is that when you end up with a true statement, and a true statement looks something like 5 is greater than 3. That's true. This really means all real numbers, or what we've been calling infinite solutions. Infinite solutions when you end up with a true statement. Now, kind of on that same idea, false statement, so when you are solving everything and you end up with a false statement, and that's something like negative 6 is greater than 4, right? Negative 6 definitely is not greater than 4. It's a false statement. This means no solution. So just to give you one example of these, we'll go back to blue here. Kind of an example on this one is that if you have 18x minus 2 is less than 6 times 3x plus 4, you would get 18x minus 2 is less than 18x plus 24. When you minus 18x from both sides, you get negative 2 is less than 24. This is true. Absolutely. Negative 2 is less than 24, meaning there are infinite solutions. And on the flip side, you might have something like 14x minus 3 is greater than 14x plus 8. So when you subtract 14x from both sides, you get negative 3 is greater than 8. That's false. We cannot say that negative 3 is greater than 8. So there are no solutions. Wowzers, great job. That was a long one. We'll see you soon.